Hello everyone, welcome back to the Valley 4 Text channel. In today's video, we'll learn how to set up a Python virtual environment, and install all the necessary libraries for a project, image classification, using OpenAI's clip model. If you've watched the previous two videos, you already know what we're building, a series of tutorials for building a smart application that automatically classifies images into different categories. We started this series with an introductory video to explain the project in full. We then added a second video explaining how to install Python and pip on Windows 11. You'll find links to these videos in the description below. Today, before we start writing any code, we need to set up our working environment. And that's exactly what we'll be doing, creating an isolated virtual environment, and installing all the required libraries for our project. So, if you're serious about building AI apps, hit that subscribe button and let's get started. Before diving into the steps, let's understand why we need a virtual environment in the first place. Imagine you have multiple Python projects on your computer, each requiring different versions of the same libraries. Without a virtual environment, you might encounter compatibility issues between these libraries. A virtual environment is an isolated container containing a separate Python installation with its own libraries. This allows you to work on multiple projects without worrying about dependency conflicts, making your projects more portable and shareable. First, let's create a folder for our project. In my case, I'll navigate to partition D and create a folder named image_classifier. Of course, you can use Windows Explorer to do this, but since Python is a scripting language, I recommend using the command line until you get used to it. So, I'll create the folder using the command line as follows. Right-click the Start menu, and from the menu that appears, click Terminal Admin. From the message that appears, click Yes to open the command prompt with administrator privileges. Now, type cd d and press Enter on your keyboard to stop the command prompt at partition D. Next, type mkdir image_classifier. You'll notice that a new folder named image_classifier has been created inside partition D. Now, type the command cd image_classifier. You'll notice that the command prompt cursor is positioned at the image_classifier project folder we just created. Now that we have our project folder, let's move on to creating the virtual environment. In Python, there's a built-in tool called venv for creating virtual environments. Let's use it to create a virtual environment called env within our project folder. If you've closed the command prompt and opened it again, make sure the command prompt cursor is on the project folder by typing cd, followed by the path to the project folder. Next, type the following command. Python -mv env. Wait a moment for the virtual environment to be created. You'll notice a new folder called env appear inside our project folder, containing a copy of Python and the core pip library. Now that we've created the virtual environment, we need to activate it. The activation process varies slightly depending on the operating system you're using. On Windows, use the following command to activate the virtual environment. env/scripts/activate. On Linux and macOS, use the following command. Source env/bin/activate. But, what happened here? A strange error message appeared. That's strange. Why isn't it working? Let's read the error message carefully. The problem seems to be related to something called execution policy in PowerShell. The message says, running scripts is disabled on this system. Ah. Now I get the problem. PowerShell has a security feature that prevents scripts from running by default. And the activation file for our virtual environment is a script. Let's try a solution to this problem. We can temporarily change the execution policy for this session only by typing the following command. Set execution policy, scope process, execution policy bypass. Excellent. Now let's try activating the virtual environment again by typing the command. env \scripts \activate. You'll notice a change in the command prompt. The virtual environment name will appear at the beginning of the line, such as env. This means that the virtual environment is now active, and any packages or libraries you install will be specific to that environment. Now, let's look at the traditional way of installing the libraries required for our project. By examining our code file, we can see that we need the following libraries. 1. OS. 2. Shootil. 3. Tkinter, for the GUI. 4. Threading. These libraries are integrated with Python, so we don't need to install them separately. 5. Torch, a PyTorch library for machine learning. 6. Transformers, a library from Hugging Face containing a clip model. 7. Pillow, for image processing. 8. NumPy, for mathematical operations. To install these libraries one by one, we use the following commands. Pip install torch. Pip install transformers. Pip install pillow. Pip install NumPy. We can also install all the libraries in a single command. Pip install torch, transformers, pillow, NumPy. In my case, I intentionally left out the NumPy library so we could see the effect when running the application. Now, these libraries and their dependencies will be downloaded, and then the installation process will begin within our virtual environment. This will take some time, so be patient. After the libraries were installed, I noticed that the command prompt found a recent version of the pip package manager, suggested I update it, and even gave me the update command. So, I'll copy the command and use it to update the pip package manager to the latest version. Now, let's learn a more professional way to manage project dependencies using the Requirements.txt file. This file contains a list of all the libraries required for the project, making it easier to install them all at once. First, let's create a Requirements.txt file in our project folder. We can do this easily by using the following command. Pip freeze requirements.txt. This command does the following. 1. Pip freeze outputs a list of all Python packages installed in the current virtual environment, along with their specific versions, in a format suitable for installation. 2. Sign on the command line takes the output from the previous command and writes it to a file. 3. Requirements.txt, the name of the file to be created or replaced, which is the traditional name for Python project requirements files. The main purpose of this command is to document all libraries used in your current project with their exact versions, enabling you or others to recreate the exact same environment elsewhere. Now, we can install all these libraries with a single command. Pip install -r requirements.txt. This command will read the requirements.txt file and install all the libraries listed there with the specified versions. Advantages of using a requirements.txt file. 1. Clear documentation of project dependencies. 2. Ease of sharing the project with others. 3. Ability to recreate the same environment exactly in the future. 4. Specify specific versions of libraries to avoid compatibility issues. Let's summarize what we learned today. 1. We created the project folder using the command prompt. 2. We created a virtual environment for the project. 3. We activated the virtual environment after resolving the activation issue. 4. We updated the pip package manager. 5. We learned 2 ways to install the required libraries. A. The traditional way using pip install. B. The professional way using the Requirements.txt file. In the next video, we'll start building the GUI for an image classification application using the Tkinter library, and we'll integrate the clip model for automated image classification. If you enjoyed this video, and learned from it, don't forget to hit the like button, and subscribe to the channel, for the next one. Also, share in the comments if you have any questions, or encounter any problems, setting up the virtual environment. Thank you for watching, and see you in the next video.